Hello, in this video, we will discuss tutorial chapter 5, question number 10. You can find this file in our Brighton. Question number 10 is about the determine and draw the shear force and bending moment diagrams for the beam given here. We have a distributed load from A to C, and then we have a concentrated load at point D, and then at point A and B, we have the um, reaction force where you need to find the unknown reaction forces at A and B. So first of all, you need to draw the free body diagram to find RA and RB, and then to see how we can work on the reaction forces and the moment. So by drawing the free body diagram, we have RA and RB at point A and B here. So the point D, we have 60 kilonewton. Between A to C, it will be distributed load, and then we convert to the concentrated load by taking the formula of area. 30 times 2 will be 60 kilonewton. So this is our free body diagram. So we have converted the distributed to the concentrated load. So we have done our step number 1. Let's go to step number 2. To determine RA, we must do moment at B. To find RA, so we consider positive counterclockwise at B. So the moment the total will be 0. So the green color shows the counterclockwise. So we have 3 arrows or the forces to be considered. First, the RA will be negative since the direction is going up. However, this side, the green shows going down. That's why negative. And then the distance will be 5 meters because 1 plus 1 plus 1 plus 2. And then for the 60 kilonewton, it will be positive, with the distance is 4 meters. And then for the next positive 60 kilonewton, it will be positive, with the distance 2 meters. As the result, you will see that RA will be equal to 72 kilonewton. And then for the RB, we consider to take the summation of the vertical forces. It's going up is positive, so RA will be positive, so the value RA is 72. And then both 60 will be negative since going down. Okay. And then finally RB will be positive since go up. As the result, our RB will be 48 kilonewton. So we have done the step number 2. Let's go for the cutting method, step number 3. Why we do cutting method? To find all the values for the V and all the values for the M. First, we are going to cut our beam starting from left to right. So our first cutting will be area A, will be after A. We have force 72 kilonewton. Our second cut will be after C. Since this is distributed load, we know that 72 later will drop by 60, becomes 12. So our next cut will be after C. And then before D, sorry, before D and after D. And also before B. So we have 5 cutting here. I'm not sure why my screen goes up whenever I click this button. So it's the 5 cutting. So every time we cut, the beam will be on our left side. So the force, shear force will be positive by going down. And then sorry for some technical problem here. Every time we cut, our V will be going down V1, and then the moment will be counterclockwise M1. So the first cut here, we can find our V1 and M1 by taking 72 minus V1 equals to 0. Since we only have one arrow at 72, so V1 will be equal 72 kilonewton. For the moment, consider positive counterclockwise summation of moment must be 0. So 72 will be negative since the direction is opposite to the counterclockwise. So M1 will be plus. Finally, we can get M1 equals to 0. So why the value 72 times 0? Why the value of the distance 0? Because after A, the distance can be any point between A to C. So we don't fix the distance. So that's why every time we cut and then after, so distance will be 0. We will see this same situation later when we do cutting after C. So next we go to the second cut. So as described here at our right bottom side here, we have the drawing of the shear force. We can see the value for the shear force is decreasing from 72 to 12 due to the 60 kilonewton distributed load, and then the line is decreasing. See, we will draw this later. So let's find all the values first. So V2 will be equals to 12 kilonewton. And then for the summation of the moment, negative 72 times 2. 2 is the distance from A to C. And then the 60 kilonewton with the distance 1. And then plus M2 equals to 0. We can find the M2 value. So the value of M2 will be 84 kilonewton. Let's go to the third cut. We have V3, M3. To find V3, we consider 72 positive because going up is positive. So the 60 will be going down, so negative 60, and V3 also going down. So we have V3 equals to 12 kilonewton. For the moment side, we have negative 72 times 3. The distance from A to D is 3 meter. And then the 60 is positive, so the distance is 2 meter plus M3 equals to 0. So M3 equals 96 kilonewton meter. For the fourth cut, we have V4 equals to negative 48 kilonewton. And then for the moment, we have M4 equals to 96 kilonewton meter, same as M3. So as you can see here, the distance after D, sorry, this case is for the M4, yes, after D, so the distance will be 0, that's why 60 times 0. So that's why we have the same result, M3 and M4. And final cut, we are going to consider before B, so the 48 kilonewton is not actually included. So I will clear the 48 kilonewton here. So as the result, we can find our V5 equals to negative 48 kilonewton by taking 72 minus 60 minus 60 minus V5. And then my M5 will be equal to 0. We have three forces, 72, 60, and 60. 72, the distance is 5 meter. 60, the first will be 4 meter. The second 60 will be 2 meter. And then we can find M5 equals to 0. So finally, we are going to draw down here. So this is our V equals to kilonewton. And then we have points C and D here. So C will be here. Here. This is A. This is B. So V1, V2, V3, V4, V5, V48, V4, V48, V3, 12, V2 is 12, V1, 70, okay. So 22, 12, 12, 48. So V1 is starting here 72, and then V2 is 12, so it will be decline or decreasing, and then CD will be remain at 12, and after 12 will be down to 48. Okay, let's say this is negative 48, and then remain at 48, and then back to B for the final force 48. So we back to 0. So the x-axis is the distance or the length from A to B. And then let's go for M1 equals to 0, M2 equals to 84, M3 equals to 96, M4 again 96, M5 equals 0. And then this will be distance M kilonewton times meter. So at point A, at point C, at point E, at point B. At point A will be 0, and then point C become 84. Let's say this is 84. And then one more 96 at point D. So between A to C, the shear force is decline or decreasing. As the result, the drawing in moment will be curved. And then between C to D, the shear force is constant. So the drawing for the moment will be incline, okay, increasing of the line. And then again, dB here constant, and there is negative. So dB will be decreasing. So this is our bending moment diagram. So we have done drawing the shear force and bending moment diagram. Okay, so that's all for this video. Thank you.